Okay, so first we're gonna start with the definition of alpha decay. So alpha decay is a nuclear decay process where an unstable nucleus changes to another element by shooting out a particle composed of 2 protons and 2 neutrons. So this ejected particle is known as alpha decay. So we can see here the large or unstable nucleus change to smaller or more stable nucleus after we ejected the alpha particle. For example, the uranium-235, which is the parent nuclide, undergoes alpha decay to form thorium-231, which is the daughter nuclide. So the alpha particle removes 2 protons and 2 neutrons from the uranium-235.
Okay, now I would like to present about the calculation, the basic equation of alpha decay. In alpha decay, the mass number of the product nucleus, daughter nucleus, is 4 less than that the decaying nuclear parent nucleus, while the atomic number decreases by 2. Okay, here is the formulation of equation. In the formulation, they have parent nucleus, total number of nucleons, total number of protons, the daughter of nucleus, and release alpha particle. Okay, here is the example of question. The solution of the question is, this equation represents the alpha decay of uranium-238 into thorium-238 and an alpha particle. The atomic number of uranium-238 is 92, while the atomic number of thorium-234 is 90. The mass number of uranium-238 is 238, while the mass number of thorium-234 is 234. The alpha particle has an atomic number of 2 and a mass number of 4.
Next, let's move to disintegration energy. But before that, what is disintegration energy? Disintegration energy is energy change of a nucleus when it undergoes radioactive decay. Okay, let's take a look at example question. The picture shows the process of alpha decay from parent nucleus americium-241 to neptunium-237. Now, in order to calculate the disintegration energy, we must calculate the difference in mass between parent and daughter nuclei first. Then, we're going to use the information given about the mass of particle X, particle Y, and the alpha particle into the formula. So the formula for disintegration energy equals to mass of parent minus with mass of daughter nuclei and times with the speed of light. Then we insert the mass values into the formula and get 1.195 times 10 to the power of negative 12 joule. To make this slightly easier to read, we can convert this to electron volts and get 7.459 mega electron volt. Next, for another example, consider the decay equation which describes the decay of polonium into a mystery element X through the emission of an alpha particle. Firstly, we must find the mystery element so we can find the disintegration energy for the decay. Recall that the atomic and mass number in decay equations must always be conserved, so we can use the information about polonium and the alpha particle to work it out. First, take all the upper part of the elements to find mass number. Then, through calculation, we get 206 for mass number, and to calculate the atomic number, take all the number in lower part and we get 82 for atomic number element X. So, the mystery element X has a mass number of 206 and atomic number of 82, meaning that it is lead or denoted as plumbum. So, using the fact that the mass of polonium particle, a lead particle, and alpha particle, we can now calculate the disintegration energy for this decay. Once again, insert all the information into our equation and we will get 1.195 times 10 to the power of negative 12 joule. Then convert it to electron volts. So the integration energy for the alpha decay of polonium-210 is 7.459 megaelectron volt.
Okay, next I will continue with the calculation kinetic energy of alpha particle. Firstly, the question asks calculate the kinetic energy of an alpha particle which has a wavelength of 12 picometers. So the solution, we can use the wavelength formula because wavelength has given which is 12 picometers. So the wavelength formula is h over p, where h is Planck constant and p is momentum. So the momentum formula is square root 2mk. K is kinetic energy. So we want the formula of kinetic energy. So we can rearrange the formula and can get the h square over 2m lambda square. So you just insert the number to the formula, but m is mass of particle, which 6.64 times 10 to the power of negative 27, and lambda, which is wavelength 12 picometer. So we need to convert picometers to the meter. So 12 times 10 to the power of negative 12, and we can calculate and get the kinetic energy is 2.29 times 10 to the power of negative 19 joules.
Next, we move to the applications of alpha decay in our life. The first one is in the smoke detectors. Smoke detectors use a radioactive element known as americium-241. The internal circuits of the smoke alarm contain two charge plates, a battery, a detector circuit, and an alarming mechanism. The connection of the circuit is made by one terminal of the battery is connected to the positive plate of the smoke detector, while the other terminal is connected to the detector of current. And then the detector of current will further connected to the alarm, and then the whole circuit will be completed by connecting the alarm system to the negative plate of the smoke detector. The americium-241 is placed in the middle and is capable of exhibit the alpha decay by releasing alpha particles into the surrounding. And then the alpha particle that been released will ionize the air molecule that presents in the surrounding. The ionization of air molecules in the surrounding will causes a significant amount of current to develop between the two plates of the smoke detector. The ionization that exists in the surrounding will occur, and the magnitude of the current will be exist and quite high. Therefore, the detector of the current does not ring the alarm. However, when in case of fire, the smoke enter between the two charge of plates and it will slow down the movement of ions in the surrounding. When the movement of ion is slowed down, it will decrease the current, and then the current will be detected by the detector, and detector will detect the decrease of the magnitude of current in the system, and therefore it will activate the alarming system and the alarm will ring. The second application of alpha decay in our life is it is used in artificial heart pacemakers battery. Pacemakers make use of the radioactive element which is plutonium-238 as an energy source that undergoes alpha decay and emits the alpha radiation. These radioactive elements are preferred to be used as full source for pacemaker batteries because the half-life of this element is nearly equal to 88 years, which can be used for a long time duration. However, the disadvantages of these fuel sources includes the inconvenient cost to the patients while traveling, problems to dispose of the gadget, and the toxicity of the element. The third application of alpha decay in our life is it is used in medical equipment. Alpha decay is used in a number of medical equipment for a diagnosis and treatment of various lethal diseases such as tumors and cancers. For example, the targeted alpha therapy, or known as TAT, the two main functions of this TAT is to destroy cancer cells and limit the damages to the healthy cell. TAT makes use of alpha particles to kill cancerous cells. For example, to treat tumors, the patient is made to ingest the lead-212 element, which is highly radioactive in the nature, and then this element will reach the tumor site and tend to release the alpha radiation into the surrounding. Therefore, it will kill the infected cell, or it will kill the cancer cell.